having systems that are super intelligent, systems that are going to kill us all or elevate us to a new status. None of that requires consciousness, right? That's a completely separate. I think it's a very important question, but it's a completely separate question.
So recently, Dario Amodei, CEO of Anthropic, he released an essay about dangers of AI technology. And like one of the dangers he mentioned is like creating bioweapons. And basically he's saying that the risk is, with very advanced and capable AI systems, average person has like PhD in virology capacity. They have like this knowledge that will guide them to create a bioweapon. So I'm wondering how you would estimate that risk. Like, is it really something that average person with average resources would be able to do if they're like really some like psychos?
I think so. I think the answer is yes, but also we've already sort of existed in that world for a long time, because you don't need a million psychos to do this. You only need one. And the world is full of well-funded bad actors who maybe already have, one can argue, maybe will, who can do this. And so, yes, it makes it easier, but the barrier is not high. This is bioweapons are not like nuclear weapons where there's a very rare key sort of enabling step and everybody knows where it is and you can track it and all that. Biologicals aren't like that, and I think the barrier to making those has never been particularly high. You need a little bit of knowledge, perhaps, but it's well within the reach of, let's say, master's degree type of students, and there's plenty of those all around the world. So yes, the AI makes it easier, but I think that risk has always been here.
Okay, so you don't perceive it as a like really serious risk or increased risk just because AI systems are becoming more powerful?
I think it's a very high risk. I first learned about the details of it in the 90s when I first went to grad school in biology, and I first realized how easy it is to do things like that. And so I think the risk is quite high, and the AI maybe raises it a little bit, but the risk is already there. Anybody who is really, let's put it this way, anybody who's motivated to do something like this is going to have the motivation to learn how to do it. You don't need AI for that. There are libraries, internet. The AI makes it a little bit easier, but there's, it's not that hard.
Interesting aspect in this that AI is not like substantially increasing that risk. That basically that risk like existed before, and it's not that with AI it's like order of magnitude improvement, right? Like increase of that risk, basically.
Again, this is not anything I'm an expert in, but imagine that you had 10,000 people who could do something horrible, and now you have 100,000 people. Okay, so tenfold increase. Does that matter? You're right. It was enough. We had enough, and now we have more. It's not obvious to me that this is certainly it will raise the number of people who can do this, but the barrier was never very high, so I'm not sure.
And also, he mentioned about mirror life. I don't know if it's like within your domain, like to educate us about mirror life and like why it's, at least in that essay, it was presented as like something like really, really serious and extremely dangerous. I'm just tapping into your background as a biologist, wondering.
There are a number of other technologies like it. So, for example, prions. You could imagine that we discover something that causes protein misfolding in a prion type of process. I think it's reasonable. Also, I would say that all of these three examples that we've been talking about is us guessing from known risks. I think the biggest issue here is not the known risks that we already know about. It's the unknowns, right? It's somebody discovers an entirely new way to create a horrible problem. Like that's also quite possible.
It is a real risk now. And maybe, like, basically I'm trying to understand, is AI like helps to increase that risk because it's such a capable technology, and the capability will only increase, and it might speed up the timeline in which people can develop mirror life?
Seems reasonable to me, but I'm not aware of any technologies that haven't been misused. I once did a poll on my Twitter. I did a poll of people, and I posed the following situation. Imagine you're Og the caveman. You're walking on your way back to your tribe, and you get this vision. You're just beset by this incredible vision of fire. Okay, so you've now figured out fire, and what you get is a vision of everything that follows after that. Gunpowder, antibiotics, metal weapons, cardiac implants, stem cells, atom bombs, airplane, like the moon landing, like the whole thing. And so now, having seen all of that, do you then go back to your tribe and show them the fire so that this can all get going, or do you continue to sit in the rain and sort of get pneumonia when it's cold and things like that? In my survey, 6% of the people, and these are people who follow me, so they're already a little bit pro technology, I think, but that 6% of the people thought that, yeah, if you had seen all of that, you should have decided not to move forward with fire. Every invention and discovery, I think, that's ever been invented, somebody has misused it for something, and I don't think AI is going to be any different. I think absolutely someone will figure out a way to create problems with it. Many others will figure out ways to make our lives better. That's just how it goes.
So do I understand correctly that you're not supporting this like doomer mindset that, like if we create super intelligence, that it will kill humanity?
There are many ways to kill humanity without super intelligence. We have nuclear weapons. We have things that degrade the environment with chemicals and with many other things. You don't need a super intelligent invention to destroy humanity. We have many, many ways of doing that. Can I guarantee that that's not going to happen? Absolutely not. The sense in which I am not a doomer is that I don't think it's inevitable. I think there are scenarios in which we flourish together, natural, artificial, and kind of symbiotic hybrid kinds of beings moving forward. I think that's possible. So I don't think we need to be a doomer in the sense that no matter what we do, we're doomed. I don't think that's true. But I'm also not going to sit here and say that every path forward is sort of rosy. I mean, humans are very good at creating problems for each other and for ourselves. And I think AI is going to be no different. We can absolutely make problems that way.
I guess in this case, with superintelligence, and to some extent, it's like maybe a reference to the side effects that you discovered in the algorithm sorting, that they're like this emergent behavior. And like if we take superintelligence and like how complex the system is, then there could be those emergent behaviors that we can't even comprehend.
Sure.
In its worldview, humans might be like some terrible, unnecessary creatures, and it will be just very easy to wipe us out. I mean, to some extent, I'm attached to humanity because I belong to that species, but like probably from, like from universe perspective, it doesn't matter. Like, okay, like humans will disappear, some other, like species will emerge. But like, if we care about, preserving humanity, don't you think that in case of superintelligence, the risk is higher because it's something that we potentially won't be able to not even control, but like not even able to comprehend?
I fully agree that there are going to be numerous things that we are ill-suited to comprehend. That's for sure. We're going to have major surprises that we are not well equipped to deal with. That's for sure. I want to take apart a couple of things, though. First, your idea of humans and that we'd like humans to continue. It makes sense. What I think we ought to do is sort of think back and make a ruling on what happened to the Neanderthals. From the perspective of the Neanderthals, there was a terrible event, right? And I'm not an expert on early hominid history or anything, but my understanding is that there was a new being that showed up that had better cooperative and cognitive capabilities. That's it. They couldn't keep the early other types of hominids couldn't keep up, and now they're gone. What do we say about that? Was that fine because here we are and we're the humans, or was that really a problem because it's not impossible that that's where we are now? Not impossible at all. I think we ought to be able to say something about that, and then after that we can say what we think the next step should be. That's the first thing. And the second thing is that you said you want humans to continue. So now we have to define what that means. I think it's interesting to ask what is really a human. What do we mean by human? I for example would be incredibly surprised if we sort of went off somewhere, came back to this planet, let's say 100 years from now, and what we found looked exactly like the same thing that was here, hundreds of thousands or even millions of years ago. The same human with the same limits on IQ and was susceptible to dumb bacterial diseases and cognitive decline and blindness and all this stuff. I would be shocked if we came back and that's what was here. I think something else is going to be here, whether that's us, whether that's some version of us. Let's dig into what a human is, and I like to think of it this way. Suppose you're going to go, you're going to go live on Mars for 50 years, and the question is, what do you want to bring with you? You get to bring one sort of agent with you, and so you think, well, a Roomba, that's kind of too boring. A dog is a lot better. And you would think, I'd like to bring a human. That would be great. I'd like to bring another human. What are your actual criteria? Well, let's see. Are you checking the DNA? You want the modern Homo sapiens genome? I don't care about DNA. Are you checking the anatomy? You want like original, kidneys and things, not some sort of, cyborg kind of thing. I personally don't care about that either. What do you care about? So I think what we care about when we say human is a certain size of the cognitive light cone. And by cognitive light cone, I mean the scale of the goals that you're capable of pursuing. In other words, the size of the biggest thing that you're able to comprehend and work towards as a goal. If there's a kind of impedance match between you and I don't mean purely intelligence, because it's not just about intelligence, it's also about compassion. I wrote a paper with some Buddhist colleagues talking about the scale of the radius of concern. Like, this is, if you tell me that you're able to care about all of the creatures on Earth in the linear range, right? Like, actually not just say it, but actually care about everybody in the same way that we all know how to care about a small number of family members. If you're actually able to do that, I would say you're not a standard human. You're something beyond that. You have a functionally bigger scale of compassion than humans have. So I think when we say human, I don't think we mean the genetics. I don't think we mean the bodies. I don't think we mean any of that stuff. I think what we mean is the cone of care and compassion, like intelligence and compassion, that we're able to muster. And as long as we hold on to that, or expand it, I mean, it would be nice to expand it. Everything else, as far as I personally am concerned, everything else can change. That's what we mean by human. But you would have to say what you mean by human.
Just to clarify, why don't you care about genome? I mean, then you can recreate like the body, the same shape.
Maybe you can, but I mean, what we were talking about here is, what is the criterion? So you have a spouse and they come back one day and say, oh my God, I just found out, it turns out my genome isn't what I thought it was. For some reason, there's something else going. I would be interested in that as a scientist, but I would be completely uninterested in that from the perspective of the relationship. Like, genome, most people spend their whole lives having no idea what a genome is, and it's fine. You don't actually need to know anything about genetics to have a human style relationship. For that level, I'm not interested. And I think, and that part is completely fine, that our genome has changed. We used to have a genome of a microbe. We now have a genome of a human. If later on we have, our genomes change to be something else, or in fact we give up the genetic code entirely and we continue with being embodied in some other kind of structure. Maybe I've read too much science fiction, but I have zero attachment to genomes per se.
So when you say about light cone, are you referring only to like cognition, or you're also including emotions, like personality, kindness, compassion, like basically like what makes, like you, what makes me, right? Because it's, as you said, like, it's not only genome, it's not only body, but that human interaction is something different. And it's not only intellectual on a cognitive scale. So I'm wondering, that light cone includes that personality as well, or it's only cognition?
I don't have a theory of emotion or anything like that. Obviously it's an important part of it. I don't have a new one. Plenty of other people have put those out. What I try to do is because again, my job is not to be a pure philosopher or a social commentator or anything like that. I try to move science forward, and so what I try to do is to develop a framework that would allow us to think about radically different types of beings all on the same scale. And so this means beings with a different origin story. Were you evolved? Were you engineered? Some combination, and composition. What are you made of? I wanted something that transcends all of those details and allows us to think about a wide range of unconventional, perhaps, beings all at the same time. And what I thought unifies all active agents, anything that we are interested in as an active being, I thought what unifies all of them is the ability to have goals, specifically to care about some particular region of the space that you live in, such that you actively work to manage that region. Based on the size of your goals, I can pretty much tell what you are. So if you tell me that you're only interested in the concentration of sugar over a tiny little region of space, and you've got 5 minutes memory of what it was before and maybe 10 minutes predictive capacity forward, I would say you're probably a bacterium. If that's the thing you care about, you're probably a microbial life form. If you tell me that you have a much bigger cognitive light cone, it's simply impossible for you to care about what happens 3 miles away 3 weeks from now, you're probably a dog. Right, so dogs can have a much larger cognitive light cone, but certain distances in space and time, they just can't care about them. If you tell me that you care about what the world food supply is going to be doing 100 years from now over the whole planet, you're probably a human, because you have a very large cognitive light cone that's in fact bigger than your own lifespan. So part of those goals are that part of it is intelligence and the ability to pursue those goals in some effective pattern. But compassion is the other part, because again, what is the range of things you can actively care about? Not just say that you care, but like actively work towards. And whether that's just yourself, or whether yourself and your four closest family members, or your community, or the innumerable sentient beings, as the Buddhists say, where that cognitive liking is, that I think is very important. So it's not just about intelligence, but the compassion side is really key.
I guess what distinguishes humans from other species, though I don't know, maybe you correct me, that we were telling stories, we're creating stories. While you were describing those different goals in different species, like I just kept thinking, but we also have this, we're creating these stories, right? And through storytelling, we actually evolved also as a species, right? And does it, this storytelling aspect also somehow fits into this light cone? Is it something that, or not important when we talk about light cone and this goal-seeking creatures?
First of all, for sure, storytelling ability can help increase the radius of your light cone. It can help you, at least for some beings, we have the plasticity to, at least to some extent, enlarge or shrink our cognitive light cone dynamically. And having the ability to share stories with others can help you to grow it. But I will also point out that I forget who it was. Maybe it was Yuval Harari or somebody said that humans are storytellers. I think all living agents, and possibly all agents everywhere, are storytellers, because in order to have any kind of a competency in navigating your environment and your space, you have to coarse grain. You can't be a Laplacian demon and try to predict every microstate that's going to happen. You'll be dead in no time. You don't have the luxury of that. So that means that you have to coarse grain. You have to develop an attention mechanism that says, I'm going to ignore certain things. I'm going to focus on certain other things. I'm going to group all these different things as one thing. This is food, or this is danger, or this is some other kind of state. And doing all of that is the earliest version of storytelling. You are telling a unique story from your perspective of how you see it's a perspective of how you see the outside world. That is a story. We humans are really good at communicating those stories and taking on other people's stories, so that's great. But the basic storytelling capacity is that's there at step one of any successful agent.
I would like to switch a little bit back to AI, and if my question is something that completely out of your expertise, or you never thought about this, let me know. But I would be interested how you perceive things now. The debate in AI is that there's version by version AI systems, and that's why many, or maybe most people, say that they're just tools and they're not conscious. And basically where research is heading is to create this self-improving, continual learning systems that have memory and potentially might develop self-identity. So my question is, how do you think that it's really important to distinguish version by version system versus continual system if we talk about their capability to have consciousness, or you don't distinguish this?
Well, I hear two very sort of distinct questions there. So the question of consciousness and the question of the importance of self-improvement in terms of intelligence and all that, I think those are separate. And I think it's really important to be clear with these words. I think that consciousness is a very particular question. And having systems that are super intelligent, systems that are going to kill us all or elevate us to a new status, none of that requires consciousness. Right, that's a completely separate. I think it's a very important question, but it's a completely separate question. With respect to self-improvement, there are certainly some life forms that appear to be fairly fixed in their capacities. Nematodes and things like that are pretty much what they are, and they don't in the short term they don't improve. In the long term, evolutionarily, they might. But of course, the ability to close that loop and improve yourself is a great engine for some kind of exponential increase in intelligence. Yeah, I think it would be hard to argue that that's not going to give rise to much more capable systems. Whether that has anything at all to do with consciousness is a much bigger question. The one thing that's missing from almost all discussions of consciousness is just a basic respect for developmental biology. The whole consciousness question is really hard because we don't have a good story of consciousness for biologicals. If you don't have it for biologicals, you can't have any strong opinions about consciousness about anything else. Let's say AIs or cyborgs or hybrids or anything else. Lots of people have really strong opinions. It's a machine. It's this and that. No one has a good story for what's going on when each of us took that little journey from being a little blob of chemicals, so an unfertilized oocyte, and then slowly and gradually we become whatever it is that we are now. That process is continuous. There is no magic lightning flash at which, well, you were chemistry before, but now you're a mind, right? Now you're the subject of psychology. Before you were just in chemistry land. Nobody has a good story for what happened there, and how the consciousness scales up, and what are the embodiments, what are the features of the physical embodiment to give you that. And until and unless we have that story, I think we have to have extreme humility about anything that we say about consciousness in AIs.
Basically, you wouldn't claim that AI systems can have consciousness or cannot, because we're still not clear about what consciousness is. So it's basically doesn't make sense to even speculate on whether or not those systems might be able to have subjective experience.
You can pick a definition for consciousness. Many people do, and that's fine. And subjective experience, whatever, that maybe needs its own. The word subjective there is doing a lot of heavy lifting, right? And it doesn't necessarily answer our questions anyway, but it's not that you can't settle on a definition. You can. The question isn't the definition. The question is, what can you say about that definition in biological? So each of us faces the problem of other minds. Let's say, to a good approximation, I know that I'm, whatever I am, I'm conscious. I don't know about my right hemisphere. I don't know about my liver. I don't, but at least the verbal part of me has a conscious experience. I assume you do, but of course I don't know that. And it's easy in biology to say, well, you are pretty much like me inside and out, and therefore, why don't we just give you the benefit of the doubt? Fine. But of course, that fails as soon as you step away. And when we step away, I don't mean language models sitting in a server somewhere. Your neighbor, who's going to have some percentage of their brain at some point replaced with technology. So that's already happening. That's for sure going to happen. What are you going to do? You're going to ask him to see whether it's like 49% or 51%. And then if it's 51%, you say, well, fine, then you're a machine. These are the difficult cases. It's not the AI. People throw around this word machine, artificial. It isn't that. It's the continuum aspect of it. Like, we were all little blobs of chemistry once. At some point, many of us will be some combination of engineered and evolved materials. And in none of those cases do we have a good story to tell about which of those things are conscious in the way that we care about, which is, for reasons of moral responsibility and rights and all that kind of stuff. If we don't have that story and we don't know what to say about our neighbor with modified body parts, how are we going to say anything about more exotic forms? I just think I'm not saying it's useless to think about it. I think we absolutely need to think about it. I'm kind of shocked at the degree of certainty that people have when they have opinions on this, because the facts on the ground don't offer any reason to have that level of certainty at all.
No, I mean, the main argument they provide is that it's made of silicon. It's not biological.
That I find that argument drives me crazy, because there's a fun story. It's only about a page long by Terry Bisson called "They're Made of Meat." Have you ever read that story? It's a science fiction story, and it's these aliens, and they come to Earth. One of them, sort of goes down and like makes some observations, and he comes back. He says, "Guys, you're not going to believe this." And he says, "What do you mean?" "Well, they look like good cognitive beings like us, right?" "Well, yeah, they seem to be doing stuff." "You're not going to believe this. They're made of meat." "What do you mean meat?" "Like the squishy proteinaceous stuff." "Well, that's insane. Like how is meat gonna?" And right, and so I mean, so what does that mean when people say they're not biological? What's the claim exactly? That the only way you get real minds is what? By being wet and squishy? Why? That doesn't make any sense. Is it because we are the product of a random search by evolution? Why would that random search have any monopoly on making minds? Why can we not engineer what evolution did? There are other things. I'm not saying that there aren't aspects of biology that are really conducive to having a high level mind. There are, and we can talk about what those are. But it isn't the material. And it isn't, at least I don't think, some other people disagree. It isn't any of the things that people normally think about. And again, if you ask people, great, so why is a biological privilege? Nobody has a good answer, and they don't, because then they fall apart. When you ask people, well, what about your dog? Yeah, definitely. What about your snake? But God, I don't think so. I don't know. And what about your turtle or your goldfish? These are major unsolved problems. We cannot have any certainty at this point.
When I spoke with other people about this, and some people, they just like strictly divide like what things or like creatures should be considered sentient and which ones should be. Like, it's me like, okay, are you playing like role of God? Who like gave you this right to decide, right? Like what is sentient and what is not? So crazy.
I think it's completely crazy. The thing is that it's unfortunate because we're going to have to decide. We actually do have to decide. But I will also point out that that decision doesn't drive the way we think it does in the following sense. A lot of people say we have to solve the AI consciousness question because it's going to determine how we treat them, right, for ethical reasons.
Moral considerations,
Moral
right?
consideration.
Yeah.
That's all great, except that we already know that pigs and cows have high level minds, that they can suffer, that they probably are not that far off from the kind of perceptual consciousness that we have. We already know this. Nobody reasonably argues against it. And yet we have factory farming, and it doesn't seem to make any, the fact that we know they have this status doesn't make any difference. I think it's disingenuous to pretend that, okay, as soon as we find out, and then you look at the way humans treat each other as well, right? And so we are, I think it's very, very weird that a lot of the concerns about AI are that we're going to anthropomorphize it. And people say, well, we're so stupid. We always tend to give false, moral standing to things that are really not us. What I see in humanity is the exact opposite. I don't see that. What I see is the extreme willingness of humans to latch on to little tiny irrelevant differences that can separate in groups from out groups. My group, now we are the real people. We really feel pain. These other ones, they're not like us. They don't need as much anesthetics in the hospital settings and whatever like that. I mean, that's a real thing, by the way. We can't pretend that simply knowing these things or having an assessment is going to have a major impact on how we treat them. We're just not that good at letting that kind of information guide our moral choices.
Do you think then it will be decided based on, okay, what is political agenda, what regulators think, what from practical standpoint is makes more sense, and then sort of impose certain rules how humans treat robots? Like, for example, there was case, I think, early this year that a streamer, he basically destroyed a robot. Basically, he was like beaten robot, and like that robot was completely destroyed, and he was sued because like the company that developed the robot, they sued that streamer because he basically destroyed their property. Okay, it's like basically someone destroys your car, of course you will be suing that. But let's say if that robot looks like human, behaves like human, still like some people will be treating it like very badly and abusingly, just because, for example, they purchased that robot. That robot is like their belonging, and basically they can do whatever they want with that robot. And like, do you remember like Westworld, TV show, like how they were treating this robot?
I don't know why we're talking about robots. Everything you just said applies to humans and animals. I mean, we have domestic abuse. We have every horrible thing you can imagine. People are doing it to other people. This is not a question of whether it looks like a human or it has this or that. I mean, this is why we have animal cruelty laws and why we have certain at least in some places on Earth, we have protections against abuse from each other. This is a major unsolved problem among humans and animals since the dawn of time. This is not anything new about robots. What are the laws going to be like? I assume we're going to have the exact same problem as we have now. In other words, there are going to be some laws, and they're going to say, okay, you can't do this to a dog, but you could do it to a fish. If you have a fishing license, it's about $10. If you have a fishing license, you can do it to a fish. You can't do it to a dog. And then so there's going to be some other place on Earth where they say, a dog, of course you can do it to a dog. No problem. And then there's going to be other places that are all worked up about elephants versus octopus versus something else. We already have this problem. This is not a robotics or an AI problem. This is a fundamental question about what do we do with information about the apparent capability of having first-person experience in other creatures that we live with. This has been with us for forever.
You think basically like AI and robotics doesn't bring anything new to the table, to the like at least dynamics in human interaction? Because it seems like they're like different, right, from like dogs, because they able to communicate with us. They will be autonomous. They will be also participating in our economy. And we don't know like to what extent that disruption will happen, right? Disruption in the economy. So like they're like different. If like other species, like basically we're like, what is like conventional thought? Human species, they are dominating the world, right? They're using the resources. Basically they can do with our species whatever they want. But with AI, the dynamic is different, because if it's autonomous system, cognitively, it's way more capable than any human in the world. It's autonomous. It has its own objectives. It impacts on the world. Then what is our interaction with them will be?
That's a slightly separate question. So where you started this was in asking about whether AI brings anything new to the table. For that, I will point out that, I mean, certainly there are some new things in terms of economic disruption and things like that. Sure. But as far as I can see, and I wrote I published a paper on this, like taking this apart piece by piece. I think the vast majority of the things that people are discussing in terms of AI are issues that we have had with each other since the dawn of time. The things about being replaced and ethical treatment of each other, and there are many. There's like a whole list of these things. These are deep existential human problems. These are not technology problems. These are problems about when people talk about the creation, like a credit for creation of things, right, and art and owners, how we treat credit in collaboration and invention, and who gets the credit for what. These things have been around forever. These are major unsolved problems. They're coming to light now, but it's kind of really shocking to see how people treat these as new issues that have just come up because this darn AI is here, where in reality, all it's doing is pointing to the fact that we as humans haven't solved it for ourselves. Whether the robot is like a dog or not, I just go back to my same point that humans abuse each other. Okay, humans abuse each other. Where when it's perfectly clear that here is a being, maybe it's your spouse, who is not just from the same species, but very very similar to you. There is some healthy percentage of the population that is not prevented by that fact from doing horrible things. Is anybody going to be worried about a robot? I don't see why, because we've demonstrated the ability to be cruel to each other. I don't think any of these are new issues.
But do you think those existential issues, they will be amplified because of the impact that AI will have on human society?
There will be specific things that come out, for example, economic disruption. Okay. And possibly, I mean, at some point for sure, but maybe it's AI and maybe it's not, but at some point for sure, there will be another kind of being on Earth that is more intellectually capable than the rest of us. Okay. That is going to happen. I'm pretty sure of it. That will create some new stressors on us. But I don't think it's going to amplify any of the basic issues, the basic questions of rights of other beings, those who can't fight, who can't fight for their own rights. That has always been here. It's at the forefront of a lot of people's concern. It's not at the forefront of some other people's concern. Talk about capabilities and IQ. I mean, if you look at the range of the population over the Earth, the amount of agency or ability to understand what's going on, control what's going on, do things for yourself that maybe are harmful to others. The scale of that between certain people and certain other people is immense, orders of magnitude different. So is AI going to exacerbate that? Yes, of course, but it already existed, is already here. Like none of this stuff is new. We haven't dealt with it up until now. And it's these are all the things that are simply going to be repeated again and again.
I mean, I guess the scale will be bigger. That's something new that we will face.
Maybe I don't know the exact demographics. I mean, I'm not a social scientist, but so let's say we have 8 billion people on Earth. If we try to make some kind of a diagram as far as who has what control over their environment, the global environment, their life, how much control they have over what happens to their life, I don't know how much you can scale that up more. I think we already have 1 billion people in poverty. I don't even know the numbers, but again, this is like this. The scale is already huge. Can you jack it up further? Sure you can. But again, I think it's already here.
You think it's not that AI will bring like completely new set of problems that humans have to deal with? These all problems already exist. We haven't figured them out. And with AI, we will continue figuring out things.
To summarize everything in one sentence, I would say that AI is certainly going to bring some new problems, but the vast majority of the problems that I hear people discussing are strikingly ancient, open, existential issues for not just humans, but for all life forms. All the AI is going to do for those things is to shine a light on them that people should have already sort of been looking at.
If we're overlooking, like, what problems you think we should look at when it comes to AI?
Fundamentally, the question of what makes for a morally important agent. and how do minds, I mean, there's a field called diverse intelligence research, which is really developing right now, and I think it's extremely important, and it's not getting enough attention. The basic question of what are we, what are the parts, what are the aspects of that question that actually matter. One of the things that I think we're going to have to do is drop a lot of pre-scientific terminology. We are saddled with a bunch of categories that are, maybe they were never really good, but they were useful in pre-scientific times, and they're really preventing us from making both technological and moral progress now. One example of that is the word machine. So the word machine is a really, so when people hear it, generally have in their mind is this idea that we have a set of things on Earth that are let's say biologicals, let's say like us, and for some reason that they don't know, but they kind of think that somebody's got this figured out. Those things are not fully encompassed by the laws of chemistry. So the laws of chemistry, of course, we have to obey those laws in physics, but we are somehow more than that. And that's somebody must know how that works. In fact, nobody knows, but people assume somebody knows how that works. And then we have this other sharp category, and these things are machines. And these are physical objects. They don't have the magic that we have, and they are like fully encompassed by the formal models that we have, be it, computation, like Turing machines and physics and so on. And so it's commonly thought that these are sharp binary categories that we can cleanly define between them, that everybody knows what those are, and that we can deal with these two categories in a radically different way. I mean, the reality is that if you insist on a mechanistic perspective, on a sort of bottom up, sort of a reductionist kind of perspective where you're looking at the parts, we are all that all of us are that kind of machine. We all obey the laws of chemistry. This idea that there are these two categories, I think, is fundamentally wrong. This idea that it's a binary distinction is fundamentally wrong. What we have instead is a spectrum. We have a gradient, and in fact, it's not just a spectrum. We all traverse that spectrum as we develop from an oocyte to a full functioning cognitive system. And so understanding how that scale up happens, how minds first enter the physical world and how they scale up, how that cognitive light cone grows from the tiny little biochemical goals of a single oocyte to the much larger anatomical goals of an embryo to the enormous light cone of a human, of a modern human. That scaling process is really what we need to be focused on, and to ask the question, what are the features of the material, right? The self-assembling material. What are the features of that material that are important for the kinds of things we care about? Alan Turing, it's really interesting to me. Like Alan Turing, who was very interested in intelligence, artificial intelligence, right? Kind of mind in all possible guises. He wrote one of the first papers on computational developmental biology. He wrote this paper on what became known as Turing patterns, on how chemicals self-organize themselves in embryogenesis, because I think he really saw quite clearly that this is the fundamental problem. How do minds enter the world in whatever kind of substrate, and how do they scale up? That to me is no fundamental progress is going to be made without paying lots of attention to that question.
Do you think it would be correct to say that by developing AI systems, we're building this like interface of new minds that enter this world? Like we're discovering these new minds with much bigger light cone, bigger than all humans combined.
I'll go with you on the first part. So I definitely think that through the efforts of bioengineers, people working in synthetic biology, artificial life, AI, all robotics, all of that stuff, absolutely we are building novel embodiments of minds. We can get into what I think that really means, but the bottom line is that, yeah, I think we are now creating interfaces into the real world for types of minds that we've never seen before, that maybe nobody's seen before. So that for sure, that make new interfaces, gain new friends. Like we're gonna get some minds that we've never seen before. That I think is true. Whether or not their cognitive light cones are currently bigger than ours, whether or not the current type of AIs that we have are that kind of system, that's a whole other question. Because we can talk about how to sort of how to estimate and try to gauge these things.
If I'm honest, I don't care about current AI systems. I care about what will happen in the future. Like, where are we going? And it seems like where, like, at least the intention is, right, of like this frontier AI labs, like to develop that, to discover that mind that is, whose cognition of its light cone is way bigger than all humans in the world. Like this is at least intention. We don't know like if it happens or not, but this is the intention, right? And resources behind it.
And I think that's in the long run, I think it's inevitable. We can argue about whether the current research paths are off ramps or whether this is where we're going. But in the long term, I think it's inevitable simply because the a priori chances that this here is the top of the line. I find that wildly implausible. No doubt there is lots of room. I think at the top of that spectrum. If evolution's poking around has not found all of that, we can give it a hand at this point, and and I'm sure those kind of beings will be here. Now they may be us at that point. I think we are not going to stay the same. We're already not the same, of course, but
Some form of mergence, merging.
yes, but not one form of merging. I think what we're looking for is freedom of what we're looking at is freedom of embodiment. I think that at some point in the future, and I don't think it's going to be very long. It might be 1 or 2 generations. Kids are going to be in school. Listening to the story of the past, like we hear about our ancient hominid precursors, where we're like, oh my god, they would step on a sharp stick and get sepsis and die. That's like, how can but they get a toothache and be driven insane from the pain, and they're like, how is this possible? There are going to be kids in the future who are going to read about us and wait, hold on. You're telling me that people would just be randomly born in a body, and they would just have to live their whole life by whatever random body they got, birth defects and all? They would just have to like that's it. That's how they would have to live. Like that's impossible. How could anybody live like that? And that's because I think that what's going to happen is we're going to gain a much better understanding of the biology of morphogenesis, of the technological compatibility of life. Everybody, assuming we don't kill ourselves off, of course, ultimately everybody's going to have whatever body they want, and that means your friend is going to have a primary sensory feel of the stock market and the solar weather, and somebody else is going to see magnetic fields and social media things or whatever. Like everybody's going to live in a slightly different world. Everybody's going to be different. I don't think there's going to be one like, here's the humans of the future and they all look like this because they've merged with AI. It isn't going to be that. It's going to be an incredible diversity of every possible way to be, is going to be occupied at some point. And some of those are going to have massively larger cognitive light cones than we have now. I mean,
but the body, the physical representation will be similar to what humans are now. It will be completely different physical representation of it.
I don't know any more than anybody else does what it's going to look like. But if I had to put money down now, the odds that it would be exactly like this seem extremely low. I mean, we're all walking around with canes and corrective orthotics and glasses and who knows what else. We all get lower back pain and astigmatism and hearing aids. I mean, we're going to stick around like this. I don't buy that for a moment. I just don't believe it. I think we are not that far off from cracking the morphogenetic code, specifically being able to communicate with groups of cells to tell them exactly what you want them to build. And at that point, not only do most of the problems of medicine go away, birth defects, traumatic injury, aging, like all that stuff goes away, but also the next step is, right, so I've always wanted some tentacles, and I want some, I'd like some gills, and why can't I see behind me in infrared? Like, let's go. I cannot imagine that coming back to Earth some number of years from now, all we're going to see is this.
I would love to talk about the Platonic space and like minds that we don't see. When I was, listening your interview about this, the thought sort of I had like, okay, there are like these different minds that we yet to be discovered. We don't like capable understanding them, and the different representations of these minds. Is there like absolute mind? Is there like a notion of like notion of God, but like not in a religious way, but like ultimate mind that encompasses all the minds and all possible patterns?
Is there a notion of that? Absolutely, there's a notion of that. Lots of people have written about this. I'm not going to be one of those people, simply because there's enough of that. Nobody needs me to kind of pontificate on that. But I don't find the idea incoherent. I think it's possible. I don't know what we do with that idea right now. I don't have a way of making it scientifically useful. So I sort of don't have a public stance on it. But of course, many people have put out that idea over the millennia of history.
Basically, you're not thinking about this because you can't translate it into like some scientific aspect. That's why it's like all like metaphysics.
I didn't say I wasn't thinking about it. I said I wasn't talking about it. Those are not the same.
What you were thinking about this?
I'll tell you what I think, but again, I want everybody to understand what I'm saying now is not anything. It is completely different than all the stuff that I usually say in these things when I have data and arguments and reasons that you should agree with me. What I'm about to say, I don't have any reasons that anybody should agree with me. I think that the basic foundation of all of science, so being able to do any science at all, rests on a fundamental act of faith, which is this idea that the universe is comprehensible, that there is something similar between our cognitive structure and the fundamental underlying nature of reality, such that we are in some sort of resonance with it, such that we are capable of understanding what happens. It's pretty clear. I mean, Hume puzzles notwithstanding, it's pretty clear that we are able to get purchase on the world. This is why we have, computers and radios and whatever. We are able to do that. So it seems perfectly reasonable to me that underlying the patterns that inform physics and biology and cognitive science and so on, that underneath all of that is some sort of a larger scale meta pattern of which all of these other patterns are fragments, reflections, aspects of some underlying deeper reality. I think that's completely reasonable. So is it possible that all the patterns, these Platonic space patterns that we study, are reflections of a deeper underlying larger pattern? Yes, I think that's possible. I've already said that these patterns I don't think are passive. I think we are these patterns. I think patterns are agents. I think they have some various degrees of intelligence, goal directedness, other types of. So that would suggest that the larger supersets of these patterns have as well. I think that seems reasonable to me.
Why we do science, why we like do something. And then, like, to me, like whatever we're trying to comprehend, we're trying to understand like who we are, where we're coming from, like what is the origin of origins, right? Like how this all happened. Have you thought about this? Like, and like, do you think it's even like possible to comprehend, like to find that like answer of how even like existence occurred? The reason why I'm asking, because when I was listening, like what you're explaining about Platonic space, like to me it felt like this kind of like to some extent like attempt, to to crack that.
That's fair, and believe it or not, we have some science coming soon on this, and basically looking at Federico Pigozzi, who's a postdoc in my lab, and I have been trying to understand what happens in a prebiotic system before there are replicators. Once you get replicators, then sort of traditional selection dynamics takes place, and then it's sort of easy to understand what's going to happen. But before that, before you have replicators, which means you don't have selection yet, you don't have differential reproduction, so evolution hasn't gotten started off the ground. So prebiotic world, I think we have a really interesting set of findings, which we should be preprinting them in February, I think, that are they basically form a kind of ratchet or positive feedback loop for agency and intelligence. Specifically, what we found is that the ability to learn and the amount of causal emergence. Causal emergence is a quantification of, roughly speaking, the extent to which the collective is more than the sum of its parts. Okay, so the rise in causal emergence and the learning ability are form of positive feedback loop that aims upwards. It has a weird asymmetry that aims upwards. If you ask what is the source of that, it isn't evolution and it isn't biology. It isn't chemistry. It's not tied to any specific chemical substrate. It isn't even physics. It doesn't depend on any facts of physics. It comes from pure mathematics. It's a free gift from properties of networks and properties of the way that the information works in causal emergence. So I think that's pretty relevant to the question you're asking, because what it basically means is that under a very wide, as far as I can tell, of a very wide range of circumstances, not just terrestrial prebiotic chemistry on Earth, but possibly all over the universe in all kinds of weird substrates, there is a baked in positive feedback loop that aims upwards in terms of intelligence and agency. and it comes directly from, like, as far as I can tell, what everything comes from is ultimately a set of patterns that are studied at this point largely by mathematicians. It seems to me that here you have an example of why specific patterns, and other people, of course, this is not a new idea in the sense that other people have suggested other basic principles that could take the place of this as well, right? This is not the first such thing that has been proposed. That, I think, is something that we can absolutely study.
Okay, that sounds exciting. Going back to like different minds and interfaces we're building, it's really frustrating to me that I'm limited by my mind and that interface that I have. Is there like a way to have direct access to all minds and deeply, like, like really grok them directly, so I don't need any interface?
I don't think that we are physical beings that occasionally get impacted by certain patterns of mathematics. I think we are actually patterns. I think patterns come in very a wide range of competencies. I think there are some patterns that are studied by people, by mathematicians, and there are other patterns that are studied by other branches of behavioral science that are sort of much more complex, and that we would recognize as kinds of minds. Basically, I do think that it is possible to have lateral interactions among those patterns without dipping, so to speak, dipping into the physical space first. And this is, Darwin thought so too. He said that mathematicians have a separate sense than other people. And what he meant by that is that they're able to perceive directly certain mathematical objects and sort of touch them and interact with them without, right, the way differently than how we do with physical objects, where that goes through the interface and through the physical world. Can you perceive other minds directly? For sure you can. You did it when you were in math class, and so you were touching some other minds that are not human minds, obviously, but also not zero. Actually the exact character of those minds we don't yet know, and I know a couple of mathematicians that have been participating in our Platonic Space Symposium that are actually trying to work that out experimentally and like ask what these things are capable of. So now again, without any empirical evidence to talk about right now, I would say that if we are able to have lateral interactions with those kinds of patterns, it stands to reason that if we knew what we were doing, we could have lateral interactions with other kind of patterns. Of course, people have reported this. There have been people all throughout history that have reported things like this. Sometimes they're taken seriously and sometimes not. But I don't think it's crazy at all because we already have examples of this with these quote unquote low level minds. I shouldn't say that because they may turn out not to be low level like that. But we already have examples of that. So I think it's quite reasonable.
Do you think like this mind altering techniques like meditation also can help to like access that latent space, or it's different?
No, I think it's probably quite relevant. I mean, I see. So there are lots of tools. I mean, education, meditation, psychoanalysis. Like there are many tools that are designed to change our cognitive architectures. And I think again, it's not unreasonable that over thousands of years, by trial and error or maybe other ways, humans have developed protocols to alter that and to change the way that we navigate that space. To 12 years or more of math classes is one way to get really good at traversing a region of the Platonic space, right? So people get really good at that. There are also other, it seems quite reasonable to me that there are other ways to spend that time to become better at exploring other regions of that space.
It's just probably for most people 12 years in math, it's not feasible. Like not everyone is like even cognitively capable of doing math. It's like quite
I'm not going to say whether, I mean, I'm terrible at math, and so I'm not going to try to say whether that's true or not. There have been numerous mathematicians who have made the claim that that's not true, and that what's terrible are the math classes. It's not the impossibility of most people getting better. 12 years is basically through high school, right? I don't know that the average human couldn't get through. Like if the educational system was such that everybody got the attention, the personalized learning that they needed, I'm not sure that everybody couldn't get through that. So I'm guessing they could.
I was more referring to like people who are doing PhD in math and
well, that's a different
with, like, this high level of abstractions.
Yeah. That's a different story. Well, everybody has, right, of course, everybody has different set of skills. Being really good at one region of that space is not the same as being good at other regions of that space.
So basically, like if you're extremely good at math, then you have wider access to those different minds. Is that correct?
I think of it as a navigation skill. Imagine you're on a landscape. There are multiple ways to traverse any landscape. You can go very carefully, sort of methodically, step by step, crawling along. This is how back when I tried to do math, that's how I would do it, like just very slowly and ponderously and painfully, step by step. But we all know those people who they start here and they go, oh, of course, and boom, and they're over here, right? They leap. They don't have to crawl the way that the rest of us have to crawl. So I think for whatever reason, some patterns, those people being the patterns, they traverse that space in a much more efficient, generative, creative way than others do. But I think that's true for all of the regions in that space. So we have the same kind of thing with emotional and social interactions, right? There's many other kinds of patterns that other people find easier to navigate. So
I think it was on Lex Friedman podcast that you said that you don't have opinion whether or not a Platonic space is finite or not. Do you develop, has something changed in your like intuition around this? Is it, again, maybe I'm like biased, like to me it feels like it could be endless mapping. It's just really hard to imagine that something like this can have some limits. But I don't know, like since you're doing this research, do you have like new developments into understanding? Is it like mapping? Is it infinite, or it has its like finite state?
It's the same issue I was mentioning before. From the science aspect of it and what we know now, I cannot say. I don't have a way of distinguishing those possibilities. If you ask me personally, and if I had to bet $100 and then you were going to tell me the right answer, I would bet on infinite. So my guess is that it's infinite, but that's a total guess. I don't know that, and I don't have any data to suggest that there isn't some effective way to circumscribe the pattern that generates all other patterns, and then that is ultimate meta pattern, like that's it, that's the source of everything. Once you've got that, you've nailed it down. I can't disprove that. I doubt it. I think the space is generative. I think it's infinite, but that's just a hunch, just a personal hunch.
I know you're very careful with sort of expressing these unconventional ideas because you want to like it tied to like experiments and science, but like if we go really, really wild, something that maybe you never said before, like what things you're like thinking about, like maybe you're thinking about to work in the future, something like, or like some unconventional things that you think nobody would understand, but like you really think that there's really something there.
I'll give you one idea that I'm working on. I sort of call it universal steganography. And the idea is this, so steganography is this, like, it's the art of hiding data within other patterns. So if you have a picture of a cat or something, if you're an artist and you want to sign it, or if you're a spy and you want to hide a message in it, there are bits that you can sort of flip that don't screw up the main pattern, that will not be obvious unless somebody knows how to read it. What I think right now, what I think is going on, and this is partly based on the algorithms work that we've done, and then a bunch of other similar work that hasn't come out yet, that's going to come out in the next 3 or 4 months. That's even more, more of that, is basically that when you make a system that has a certain, it's machine-like in the sense that it obeys laws. Those are the laws of chemistry, the laws of physics, algorithms. If it's a computational system, maybe there's an algorithm that says exactly how it's going to work. There's the part you force it to do, right, which is the algorithm or the laws. There's the part that it has to do. But in between those, there's a weird. This is you wanted something weird, so here's something weird. I don't even know how to really describe it well. In between, there are spaces in between the algorithm. You wouldn't think so, and people don't think so, because we've had well over 100 years of this notion that the algorithm tells you exactly what to do, and that's true. And there's no miracles in the sense that the system absolutely does what the algorithm says for it to do. But it turns out that there's a weird sense in which in between those steps are things that are neither prescribed nor forbidden by the algorithm. And in those spaces, systems, even very minimal systems, and this is the shocker, and it doesn't take a complex life form or anything like that. Like even dumb, like really simple minimal systems do this. They have a kind of intrinsic motivation that comes through in the spaces between the algorithm. It's the stuff the algorithm doesn't forbid, but also it doesn't ask them to do. And yet they do things. These are not just randomness or a complexity. These are things that would be recognizable to any behavioral scientist. Various problem-solving competencies, homophily, like these kinds of things. What I suspect, and so here's a total conjecture. This ability for forms to come through these physical interfaces is universal, and it's steganography in the sense that it tries to squeeze in functionally. It sort of flows into all the spaces in between everything. In other words, all the algorithms, all the machines, all the anything we build, any interface we build, it has the obvious things that are easy for us to distinguish, but all the interesting stuff, what people consider to be freedom and choice and in consciousness and like all of those things are the things that ingress into the spaces in between. It's interesting. It's like steganography in the sense that it's not allowed to mess up the obvious thing. So when that data come in, like the sorting algorithm, it has to sort, and it sorts. The stuff that comes in doesn't prevent it from sorting. It still has to sort. But whatever spaces are left get filled in, and they get filled in with these other patterns that sort of squeeze in there. It's like this, like quantum foam, kind of supposed to be everywhere. These like this fog of virtual particles that's in the vacuum. It's like that. It's some kind of Platonic foam or something that is basically in squeezes into everything. And I think it's shy, but it isn't. But it isn't invisible. We can develop tools to start to see it, and we're doing that in our lab, and hopefully other people will as well. You can observe it, just like you can observe quantum foam if you're really careful. You can set up a Casimir effect, and you can actually catch these things happening, but you got to be really subtle about it. The same thing is here. So there you go. That's my weird idea that I think there's a kind of Platonic foam almost that squeezes into all the obvious things that we already know how to look at.
Those are like also minds that would like to manifest themselves.
I think so. Now remember that to me, I see a real continuum of minds, such that some of them are extremely minimal, like extremely minimal. They're not zero, they're minds, but they're extremely small. And so these are not. I'm not saying there's a human level intelligence under every rock. This is not an animist view like that. What I am saying is that there are unexpected competencies that are not well handled by the current paradigms of Turing machines and physics and so on, that you can find in all kinds of systems if you're willing to look. The determination of what their psychology is, like what they're like, it's an empirical question. We don't know. We can't guess. We can't decide that by a linguistic definition. It's not philosophy. You can't do it from an armchair. You have to do experiments, and when you do, you're universally surprised. So far, we've been incredibly shocked by these things.
Would it be correct to say that could it be like translated to like understanding of human, like, so we also following certain like algorithm, but also we have this different like emergent behavior like that fills out, right? Like what in case of humans, what is that? Like you mentioned already, like consciousness.
I think that's reasonable, and I mean I don't like the word emergent usually, but I think it's reasonable. I think one could claim that what we see in the algorithms is an incredibly minimal model of what people consider to be free will. Okay, I mean, I'm not going to try and do free will in 6 minutes here, but here's the thing about it. Like Dan Dennett had a very impactful argument. He said, look, at the level of physics, we only know two kinds of things. We know the things that inevitably cause other things, so deterministic kind of causes, and then there's quantum randomness. Neither of those things are what we mean by free will, right? We don't mean that it's caused by prior causes without any ability to swerve. We don't mean that it's random. That's not free will. That's just randomness. Therefore, there isn't any. That was the argument, and that makes sense if you buy the standard picture of what's going on in machines and algorithms and so on. But what we see is, and again, this is an extremely minimal version. I'm not like people go crazy when I say this stuff because they think I'm saying that these things are sitting there, that bubble sort is sitting there composing, sonnets and things. And that's not what I'm saying. But it is a very minimal model of the following. There are the things we forced it to do, and that's the algorithm. And then there's some other stuff that it's doing that we never asked for. We had no idea it was there. 80 years, people have been playing with these algorithms for 80 years. Every CS 101 student has to study these things in school. Nobody had noticed this before. They're things that are not in the algorithm. One could say that we found a kind of third thing. It's not determinism, and it isn't quantum randomness. These things are, in fact, not deterministic algorithms, and they're classical. They're fully classical, if anything is. But there is this weird third thing, which you can try to call like intrinsic motivation or something. And all I can say is that I don't know what's going on with humans or anything like that. But I can just say, if these simple things already have a small version of that, how strange would it be to assume that something as complex and multi-scale as a living body wouldn't exploit the hell out of those effects. I think evolution notices them immediately. Evolution uses them as kind of free lunches, things that living beings do that evolution doesn't have to spend time specifically evolving. And I think the way that bodies evolve exploits those like crazy. And I think again there's a positive feedback loop in that if you're good at being the subject of these ingressing patterns, you become more complex and successful. To the extent that you become more complex and successful, you're a better interface for richer and more complex and more successful patterns. Again, there's going to be this kind of like bootstrapping where I think evolution did not fail to notice this amazing kind of relationship. I think probably in the end, the proper story of free will, it's not going to be told about by redefining deterministic chemistry. It's not going to be told by some sort of quantum randomness that we're going to redefine free will as that. I think it's going to be this. I think it's going to be the ability for patterns to kind of soak into the spaces between the things that we call algorithms.
And we label it as a free will.
I mean, I don't know. People have different definitions for free will. I mean, first you have to say what are you free from? Because if you're free from your own psychological drives, then again you're a dandelion seed in the wind. And I mean, that's not what we mean by free will, right?
Those things that are happening, that are not deterministic. Like we still trying to understand what they are. Like you mentioned that they're like some like intrinsic motivations. Is it like should we label it, or like we don't want to label them now, but we're just like trying to observe them and see like how they're.
The labels aren't terribly helpful, except that they help you to develop tools and formalisms for dealing with them. So when these simple things have these intrinsic motivations, that's a call for us to develop tools to learn to recognize them, learn to suppress them in systems where you don't want them, learn to facilitate them in systems where you do want them, learn to be humble about it in the case of AIs. When people say, I know what this thing does, I make it myself, it's just linear algebra, I write the code. If we didn't know what bubble sort could do, what are the odds that we truly understand what this thing is doing? And it may have nothing to do with the language that it's using. The speech that is coming out may have nothing to do with the actual intelligence that's there. So I think we have to have a lot of humility about that. That's the only reason to label these things is to be able to develop some kind of framework for moving forward with it.